Let us take another physical quantity called weight density. Weight density. What do you mean by weight density? It is total weight upon total volume. Total weight upon weight of a given body per unit volume. Per unit volume is called its weight density. Is called its total weight upon total volume. Total weight upon what is unit of weight? Weight means what? Gravitational force. Weight means for force. What is the unit? Newton. For volume. So this is now MKS unit, and instead of Newton, what will write in CGS? Instead of meter cube, what will write in CGS? Centimeter cube. Now this is the relation between MKS and CGS units of weight density. Let us prove this. Come on. These and these are the respectively MKS and CGS units of weight density. And now dimensional formula for weight density is this: m raised to 1, l raised to minus 2, t raised to minus 2. How? You can write for force. For force, what is the dimensional formula? M raised to 1, l raised to 1, t raised to minus 2. For volume, l raised to 3. So now this is m raised to 1, l raised to 1 minus 3, minus 2, t raised to minus 2. Correct? Same formula written here. Okay? Now start with this formula. Here you write MKS and here you write CGS. Instead of 1 m in MKS, how many m should I write in CGS? 10 raised to 3m. 10 raised to 3m. Here it is 10 raised to 3m. Whole raised to 1. Don't forget. Instead of 1 l in MKS, how many l should I write in CGS? 10 raised to 2l. Whole raised to minus 2. Instead of 1 t in MKS, how many t should I write in CGS? 10 raised to 0 t. Whole raised to minus 2. Now 10 raised to 3 into 1, 3. 2 into minus 2, minus 4. 0 into minus 2, 0. M raised to 1, L raised to minus 2, T raised to minus 2. Base is same, addition of powers. 3 minus 4, minus 1. Same dimensional formula written here. Now this will give you MKS unit of weight density, which is Newton upon meter cube. This will give you CGS unit of weight density, which is Dyne upon centimeter cube. So what is the relation? 1 Newton upon meter cube is 10 raised to minus 1 Dyne upon centimeter cube. Got it? Written this much. Right, next. Using dimensional analysis. Using dimensional analysis. Obtain relation between MKS and CGS units. MKS and CGS units of universal gravitational constant. Universal gravitational constant. What is it done? MKS and CGS units of universal gravitational constant. See, I am giving you a hint. Hint I am giving you, look here. We know Newton's universal law of gravitation, look here, mathematically, F equals to G m1 m2 upon r square. So find out G. It will be F into r square upon m1 m2. Correct? So now MKS unit of G is equal to, come on, for force it is Newton, distance square, meter square, kilogram into kilogram, kilogram square. Then CGS unit of G. Come on, instead of Newton, what should I write? Dyne. Instead of meter square, should we write centimeter square? And here what should we write? Come on, gram square. Remember, gram symbol is not GM, only G. Only small g, not GM, okay? Only small g. And now, dimensional formula of G. Dimensional formula of G. That is, you should write in such a bracket. Come on. For force, m raised to 1, l raised to 1, t raised to minus 2. For distance square, l raised to 2. M raised to 1, m raised to 1. So it is m raised to 2. Let it be separately. M raised to 1, m raised to 2. Okay. Now, m raised to 1 is getting cancelled. है ना? This m raised to 1 will go up. M raised to minus 1. L raised to 1 plus 2, 3. T raised to minus 2. Correct? So instead of this dimensional formula, you start with this. You will start with this, okay? And you know relations. You know these relations. You will put them. You will simplify, okay? Get it.
1 kilogram, 1 Newton into meter square upon kilogram square. 1 Newton into meter square upon is equal to 10 raised to 3 9 centimeter square upon gram square. Right, next. Using dimensional analysis, prove that density of water in MCAS is 1000 kilogram upon meter cube. 1000 kilogram upon meter cube. Right. MCAS and serious units of. That is the answer. MCAS and serious units of density are. What is density? Mass upon volume. So kilogram upon meter cube and gram upon centimeter cube. Right. Kilogram upon meter cube and gram upon centimeter cube. Full stop. Its dimensional formula is m raised to 1 l raised to minus 3 t raised to 0. M raised to 1 l raised to minus 3 t raised to 0. Okay. Now follow the same procedure. You should start with the dimensional formula of density. Okay. Correct. 1 kilogram upon meter cube is equal to 10 raised to minus 3 gram upon centimeter cube. Okay. Now listen, everybody. What is density of water which you know? 1 gram per centimeter cube. Say 1 gram per centimeter. And what is the value have you got? 10 raised to minus 3 gram per centimeter cube. Okay. So just write multiplying by 1000 on both the sides. Multiplying by 1000 on both the sides. Come on, what do we get? 1000 kilogram upon meter cube. 1000 kilogram upon meter cube is equal to 1 gram per centimeter cube. Isn't it? 10 raised to minus 3 into 1000. What is it? 1. What is it? 1. So 1 gram per centimeter cube. Right? So what you know is 1 gram per centimeter cube, but in MCAS it turns out to be 10 raised to 3000 kilogram upon meter cube. Got it? Right, next. What is called pressure gradient? What is called pressure gradient? Obtain relation between its MCAS and CGS units. Right. Rate of change of pressure. Rate of change of pressure with respect to length. Rate of change of pressure with respect to length is called pressure gradient. Is called pressure gradient. It is total pressure upon total length. Total pressure upon total length, which has dimensional formula. Come on. For pressure, what is it? M raised to 1, L raised to minus 1, T raised to minus 2 upon L raised to 1. M raised to 1, L raised to minus 1, T raised to minus 2 upon L raised to 1. So what have we got finally? M raised to 1, M raised to minus 2, T raised to minus 2. Very good, very good. M raised to 1, M raised to minus 2, T raised to minus 2. Okay? Right. Its MKS and series units are. Its MKS and series units are. Newton upon meter cube and dyne upon centimeter cube. Newton upon meter cube and dyne upon centimeter cube. See that relation already we obtained. Correct? 1 Newton upon meter cube equals to 10 raised to minus 1 dyne upon centimeter cube. Correct? Simple. Look at this second application now. Look.
What is the second application? To verify whether given physical equation is dimensionally correct or not. For that we use one principle which is called law of homogeneity of dimensions. Law of homogeneity of dimensions. What is that law? I am showing you. Look. Can you write so? Can you write so? 3 kilogram plus 4 meter is equal to 7 second. Can you write so? 3 kilogram plus 4 meter equals to 7 second. Can you write so? Why? Kilogram can be added with kilogram only, or meter can be added with. So you can make addition or subtraction of identical physical quantities. Identical, and then that equation will be dimensionally correct. Dimensionally correct. So when any equation is dimensionally correct, at that time what happens? All the terms indicate identical physical quantities. Indicate and when all the terms indicate identical physical quantities, meaning thereby they will have same dimensional formula. They will have same dimension. So what is principle of homogeneity of dimensions? Very simple. When given physical equation is true, when given physical equation is dimensionally true, it's all the terms have same dimensions. It's all the terms have same dimensions. Or speak reverse. If all the terms in a given physical equation have same dimensions, then that equation is said to be dimensionally correct. Dimensionally correct. Okay, right. Law of homogeneity of dimensions. Law of homogeneity of dimensions. Law of homogeneity of dimensions. See the spelling? HOMO, then GENEITY. Homogeneity of dimensions. Right. If all the terms in a given physical equation have same dimensional formula, then that equation is said to be dimensionally correct. Dimensionally correct. Look, see this example. Suppose given equation is this: d equals to v0t plus 1 by 2 at square. Remember, terms are getting separated by sign of plus or minus. Sign of. So how many equations are there? How many terms are there in this equation? 3. This is number of terms. 1, 2, 3. Correct. Terms are differentiated by plus or minus sign. Plus or not by the sign of multiplication or division. Okay? Come on. And you don't bother whether the particular term is on left side or on right side. You don't bother. You count total number of terms. Total number of terms. Right now it is 3. Right now it is 3. Now, dimensional formula of first term. Correct? It is distance. Distance means what? Yeah, length. L is to 1. Dimensional formula for second term. What is second term? V0 into T. Come on, velocity, L raised to 1, T raised to minus 1. Time, T raised to 1. So it is L raised to 1. Minus 1 plus 1 will cancel. Come on. Last one is 1 by 2, 8 square. 1 by 2 is mathematical number. 1 by 2 is? We have to write dimensional formula only for physical quantities. Only for? 1 by 2 is not a physical quantity. Okay? So any numerical number is there. To discard it, don't consider. Write down for acceleration. Come on. L raised to 1, T raised to minus 2. What about time square? T raised to 2. Minus 2 plus 2, T raised to 0, adding 1. So it is L raised to 1 now. So what do you notice? Here also L raised to 1. Here also, here also. So all the three terms have same dimensional formula. All the three terms have same dimensional. So given physical equation is dimensionally correct. Dimensionally correct. Wait. This is physically also correct. Physically also correct. Don't you know three equations of linear motion with constant linear acceleration? Among those three equations, this was one of them. Come on, D equals to V0T plus 1 by 2, 8 square. This equation is physically also correct. Physically also correct. But in the examination, instead of 1 by 2, if they give any another number, say 3 by 4, say 3 by 4, then here whether it is 1 by 2 or 3 by 2 or 3 by 4, whatever it may be, we are not going to write any dimensional formula for any numerical number. Correct? So in that case also, you will have same dimensional formula for all the terms. Then you will write dimensionally correct. Dimensionally correct. But instead of 1 by 2, when you write any another number other than 1 by 2, it will be from physics point of view, it will be wrong. It will be wrong. Correct? So given physical equation, if it is physically correct, it has to be 101%, it has to be dimensionally correct. Dimensionally correct. But if given physical equation is dimensionally correct, it is not necessary that it should be physically correct. It may be, it may not be. It may be, it may not be. Okay? Right now we are not verifying the physical validness of a given equation. We are verifying dimensional validness. Dimensional validity of a given equation, not physical validity. Okay? Fine. Write this way. Here, all the terms have same dimensional formula. All the terms have same dimensional formula. Hence, given physical equation is dimensionally correct. Given physical equation is dimensionally correct. Right, next. Check dimensional validity. Check dimensional validity of following equation. Following equation. Write that equation. P plus half rho V square plus rho GH equals to mg upon A. P equals to pressure, right below that. P equals to pressure, rho is density, V is velocity, G is gravitational acceleration, H is height, M is mass, A is cross-sectional area. First of all, tell me how many terms are there? 4. How many terms are there? 4. Wait, look. For pressure, everybody knows. You written last time in the notes, correct? Density, velocity, density. This is gravitational acceleration, means it is acceleration only. It is acceleration only. H is height, which is length, and come on, M is mass, and A is cross-sectional area. For area only, okay? Right. Find out. This way you find out. Put all the terms one by one in such bracket, okay? Thereby you are finding dimensional formula.
Ready? Jasmine? Ready? Dimensional A, correct. Krishna? Ashish? Right, next. Check dimensional validity of following equation. Dimensional validity of following equation. That is equation half mv square plus half kx square equals to p into t. P into t. M equals to mass, v equals to velocity. M equals to mass, v equals to velocity, k equals to force constant. Force constant of elastic spring. Sometimes we call it spring constant. Spring constant. P is power, T is time, and x is displacement. X is displacement. Okay. See, for force constant you may not remember. Look, you know, if you have got a spring with having force constant k, you want to elongate it by amount x. In order to increase length of elastic spring having force constant k by amount x, the external force required for that is how much? F equals to k. F equals to? Find out k from here. F upon x. Of course, everybody knows for distance. Come on, length. So L raised to 1, L raised to 1 getting cancelled. M raised to 1, L raised to 0, T raised to minus 1. What is P here? Power. T is time. Okay, find out. For mathematical number, you don't have to write anything. Right, next. Check dimensional validity. E equals to under top p square c square plus m0 raised to 2 c raised to 4. How many terms are there? 2 terms. One on left side, one on right side. See, square root of this term, suppose this is x, suppose inside part is x, suppose. So e equals to under root of x, e equals to, so under root of x means what? One term. E means another term. So there are only 2 terms. Okay? You want to have 3 terms? You want to have 3 terms? Take square. Take square on both the sides. Then this square will be common. When you take square, square root will vanish. So p square c square plus m0 square c raised to 4. Correct? Correct. Now this is one term, this is another term, this is third term. Okay? You write this way. Find out for all the 3 terms, you find out. What is E? Write the specifications. E is energy. E is energy. P is momentum. P is momentum. C is velocity of light in vacuum. Velocity of light in vacuum. Ultimately it is velocity only. M0 is rest mass. M0 is rest mass. Mass of a particle in a state of rest. Again it is mass only. It is mass only. Dimensionally correct.
We now go for the last application to derive formula of certain physical quantities. Let us derive formula of periodic time of a simple pendulum. Look, last time we saw the definition of simple pendulum, remember? Come on. Here is small and heavy body suspended from rigid support with the help of this string. This is point of suspension. This is center of gravity of suspended body. This is called length of simple pendulum. Correct? Now when you disturb it slightly from equilibrium position, it will oscillate in the vertical plane about this equilibrium position this way. going from one end to another end, coming back from another to first end. Going this way and then coming back this way. So one oscillation is over. One oscillation is over. Time taken to complete one oscillation. Time taken to complete is called periodic time. Is called a small and heavy body suspended from rigid support with the help of light, untwistable, inaccessible string capable of oscillating in a vertical band about equilibrium position is called simple pendulum. Is called time taken by simple pendulum to complete one oscillation is called its periodic time. Is called its how to derive its formula. I am showing you. Look, you have to start like this. Suppose first T is proportional to, look here, m raised to a, proportional to L raised to b, proportional to G raised to c. Correct? You have to think of possible dependent factors on which capital T depend. Capital T may depend. Capital T may depend. How to think of those factors? I am showing you easy way. Instead of one simple pendulum, you just consider two simple pendulums. How many? Two. Just think mentally, how many ways they can differ. How many ways they can differ. In both the pendulums, the suspended body might be having different mass. Might be having different mass. One may be lighter in weight, one may be heavier in weight. Correct? So it may depend on mass of suspended body. Correct? One may be short, one may be long. One may be short, one may be long. So length may differ. Length may differ. One you are oscillating here, another you are oscillating at another place. At another place. So when you change the place, then gravitational acceleration may change. May change. Depending upon that, periodic time of simple pendulum may change. Okay. So these are the possible factors on which T may depend. T may depend. Okay. But at present we don't know with what power T is related to M, L and G. The powers of M, L, G we don't know. So we assume those powers come on A, B and C. Where values of A, B, C we have to find out. We have to find out. Okay. Now as a combined dependence we can write T proportional to multiplication of all this. M raised to A, L raised to B, G raised to C. And therefore T equals to, write some proportionally constant, capital K, and then below this you are supposed to write this way, where capital K, you know what is capital K? It is dimensionless proportionality constant. Dimensionless proportionality constant. Dimensionless proportionality constant. Dimensionless proportionality constant. And what about A, B, C? They belong to R. They belong to R. They are real numbers. We have to find out their values using dimensional analysis. Using dimensional analysis. Wait. Just give this as equation number 1. Then you have to write dimensional formula on both the sides in equation number 1. Come on, for periodic time, M raised to 0, L raised to 0, T raised to 1. Right? Come on, for K, because it is dimensionless, don't write anything. For mass, M raised to 1. Don't forget to write the power. Power is A. Come on, gravitational acceleration, sorry, this is length. This is length, this is L raised to 1. Whole raised to B. Come on, gravitational acceleration. It is some sort of acceleration only. For acceleration, L raised to 1, T raised to minus 2. Minus 2. For velocity, it is L raised to 1, T raised to minus 1. For acceleration, L raised to 1, T raised to, take care, whole raised to C. And now, M raised to 0, L raised to 0, T raised to 1. As it is, come on, M raised to 1 into A, L raised to 1 into B, B, L raised to 1 into C, C, correct? L raised to B into L raised to C. Base is same, addition of powers B plus C. Come on, T raised to minus 2C. And now, comparing powers, powers. of m, l and t. Come on. Compare the powers of m. Here it is a, here it is 0. So a equals to 0. Whichever values you get, you should encircle them. Come on. T is to minus 2c and here t is to 1. So minus 2c equals to 1. Minus 2c equals to 1. So c equals to minus 1 by 2. What about power with respect to L? Come on, b plus c and here 0. B plus c equals to 0. But b plus c is how much? Minus 1 by 2. That equals to 0. So b equals to 1 by 2. Fine. So we know values of a, b, c. Values of a, b, c. Let us put them at a time in equation number 1. So from equation 1. From equation 1. Come on, start with this. T equals to k into, come on, m raised to a. M raised to what is a? 0. Come on, L raised to b. What is b? 1 by 2. Come on, g raised to c. C is how much? Minus 1 by 2. Now m raised to 0 is 1. So write k as it is. L raised to 1 by 2 as it is. But this g raised to minus 1 by 2 you can transfer in the denominator. G raised to plus 1 by 2. Correct? So now t equals to k. Come on, 1 by 2, 1 by 2. Power you can take common. L by g whole raised to 1 by 2. Right? So t equals to k. Come on, under root of L by g. Value of proportionality constant, remember, it is determined experimentally. It is determined. If it is given to you in the statement, you may write. If it is not given to you, leave this as a final result. Leave this as final result. In this case, practically we find value of k to be 2 pi. How much? 2 pi. So if you are given, you must substitute here 2 pi. T equals to 2 pi under root L by g. Okay. Right. A small liquid droplet with density d, radius r, density small d, radius small r, and surface tension small s, performs small oscillations on a horizontal surface. Performs small oscillations on a horizontal surface. Full stop. Using dimensional formula. Using dimensional analysis, right? Using dimensional analysis. Prove that its periodic time is equals to under root of dr cube upon s. That given dimensional formula of s, surface tension, you are given m raised to 1, L raised to 0, T raised to minus 2. Okay? Look. We want formula of T. Anna? We want formula of T. And we are asked to prove this result this way. What does it mean? This depends on density, this depends on radius, this depends on surface tension. On which three factors does it depend? Density, radius, surface tension. Don't write, look here. So in the beginning you write, suppose T proportional to, come on, D raised to A, come on, R raised to B, come on, S raised to C. Correct? So values of A, B, C you have to find out. Right? And finally you will get this result this way. You will get it this way. T equals to K under root of dr cube upon S. You will get it this way. What you want to show is this. What you are getting is this. What does it mean? That K must be 1. K must be 1. Then we will get this result. Okay? So finally we should write K equal to 1. K equal to 1. I'm only Density you know radius, and only the Habeas formula which you were not knowing, that was about surface tension, already given.
You get A equal to 1 by 2, B equals to 3 by 2, C equals to minus 1 by 2. 1 by 2, 3 by 2, minus 1 by 2. Getting? P equals to K. Come on, D raised to A is 1 by 2. Come on. R raised to B. B is 3 by 2. And S raised to C. C is minus 1 by 2. Correct? This is 1 by 2. This is 1 by 2. T equals to K. Come on. D raised to A. Come on. R raised to B. S raised to C. A will come out to be 1 by 2. Come on. B 3 by 2. And C equals to minus 1 by 2. So let me write values of A, B, C. Come on. K as it is. This one I may write this way. D raised to 1 by 2. This is R raised to 3. Whole raised to 1 by 2. And this S raised to minus 1 by 2. I am bringing down. S raised to plus 1 by 2. 1 by 2, 1 by 2, 1 by 2. I can take common. Come on. So it is DRQ upon S whole raised to 1 by 2. Then power is 1 by 2. It is square root. Square root of DRQ upon S. This is what we are getting. What we were asked to prove. We were asked to prove this result. D equals to under root of. Come on, DRQ upon S. So match this two. So K must be 1. K must be 1. Ready?
Yes.
Right, next. Using dimensional analysis. Prove that. When a body of mass m is raised through height y, comma, its gravitational potential energy with respect to initial level becomes U equals to mgy. Right into bracket. Take proportionality constant to be 1. Correct? Look. We want formula of capital U. It depends on M, G and Y. It depends on M, G and Y. So what we should start? Come on, U proportional to common everybody. M raised to A, G raised to B. Come on, Y raised to C. Then further you know. This is potential energy, means it is energy. This is mass, this is gravitational action, this is height. Okay. Right, next. Velocity of sound. In air depends on number 1, dimensionless constant gamma, dimensionless constant gamma, comma, pressure P and density rho of air. Taking proportionality constant, taking proportionality constant as under root gamma, comma, obtain formula of velocity of sound in air, velocity of sound in air. Look, it depends on three factors then, but this gamma depends on gamma that will appear, that will reflect in proportionality constant, that will be getting reflected in proportionality constant. Okay, so we don't write it, we write this value here. V proportional to, come on everybody, P raised to A, come on, rho raised to B, correct? So finally get, come on, V equals to K, come on, P raised to A, rho raised to B, है ना? Once you know the values of A and B, then you may put K equals to under root of gamma here, okay? And P is pressure, rho is density, V is velocity. Equals to 1 by 2, P equals to minus 1 by 2. Got it? Yes. And when you put them here, look, V equals to K, come on, B raised to A is how much? 1 by 2, rho raised to B is how much? Minus 1 by 2. And this is under root gamma, gamma means gamma raised to 1 by 2, P raised to 1 by 2, and this you can bring down, rho raised to 1 by 2. So 1 by 2, I can take common, gamma P upon rho, all raised to 1 by 2. So finally it is under root of gamma P upon rho. Gamma P upon rho. Volume of liquid coming out of horizontal pipe of inner radius small r and length L having pressure difference P, having pressure gradient P dash equals to P upon L. P dash equals to P upon L. In unit time is V equals to the proportional constant P dash raised to A, R raised to B, eta raised to C, where eta is viscosity coefficient. And V equals to volume flux, capital V equals to volume flux, that equals to total volume upon total time. Volume flux means total volume upon total time. Volume per unit time, it is called volume flux. Right? And write note, pressure gradient means total pressure upon total length. total pressure difference upon total length. Pressure gradient means total pressure difference divided by total length. And take proportionality constant. Take proportionality constant pi by 8. Pi by 8. Pi upon 8. Okay. See, I am giving you a hint. Look, P dash is given to you. It is P upon L. Pressure gradient is pressure upon length. Pressure upon length. So what about your dimensional formula for pressure gradient? Come on, for pressure, m raised to 1, L raised to minus 1, D raised to minus 2. For length, come on, L raised to 1. Now come on, m raised to 1, L raised to minus 1, minus 2. D raised to minus 2. Wait. Now from here we can make out this B is proportional to, come on, P dash raised to A, come on, R raised to B, come on, eta raised to C. Okay? What is P dash that you know now? Correct? R, radius, for length. Na? For radius you take for length. Come on, eta viscosity, coefficient. Viscosity, last time we found out. In the notes, m raised to 1, m raised to minus 1, t raised to minus 1. M raised to 1, m raised to minus 1, t raised to minus 1. Remember? Okay. Now what is this B? It is volume flux. There. You written in the notes. It is volume upon time. There. So L raised to 3 upon T raised to 1. L raised to 3 upon T raised to 1. At the end you may take A equal to pi by 8. And P dash you may write P upon L. P dash you may write later on P upon L. Once you get the final answer, in that you can put P dash equals to P by L. A equals to 1, B equals to 4, C equals to minus 1. A equals to 1, B equals to 4, C equals to minus 1. For B, have you taken L raised to 3 upon D raised to 1? L raised to 3 upon D raised to 1. It is volume flux, volume upon time. Look here now. K. What is K given to you? Pi by 8. What is P dash? P by L. And whole raised to A is come out to be 1. R raised to B, B is 4. Eta raised to C, C is minus 4. Now take it down. So it is pi, P, come on, this is not dash, this is 1. Power is 1. Pi P R raised to 4 upon 8. This eta will come down, eta, and this L is there. The final formula is pi P R raised to 4 upon 8 eta. Pi P R raised to 4 upon 8. This result is called Poisson's law. Poisson's law. Okay. And last, viscous force into bracket capital F, exerted on small smooth spherical body, small smooth spherical solid body, small smooth spherical solid body, radius small r, moving with velocity v, in a large stationary viscous medium, having viscosity coefficient eta, large stationary viscous medium having viscosity coefficient eta, depends on eta r and v, eta r and v, eta comma r and v, using dimensional analysis prove that f equals to 6 pi eta so proportionality constant will be 6 pi. Proportionality constant will be 6 pi. Now you have to start. Look, suppose f proportional to come on eta raised to a, come on r raised to b, come on b raised to c. है Then you can write combined dependence. You have to find out values of a, b, c. Correct? What is eta? Viscosity coefficient. Dimension formula m raised to 1, l raised to minus 1, t raised to minus 1. For radius l raised to 1. For velocity l raised to 1, t raised to minus 1. Okay? For force, though it is viscous force, it is force.
Look, what are the limitations of dimensional analysis? First, in each of the derivation, what we had done, if you remember, we were getting three equations relating the powers of m, l and t. Now there is a universal rule in mathematics. Out of three equations, you can get maximum 3 unknown quantities. Maximum 3, not more than 3. Correct? So if any physical quantity depends on more than 3 physical quantities, its formula cannot be derived using dimensional analysis. Okay? That is the first drawback, first limitation. Okay? Then second is that if particular physical quantity depends on trigonometric function, like sin theta, cos theta, tan theta, then its formula cannot be derived using dimensional analysis. Third, if any physical quantity depends on exponential function, exponential functions are those which have power to the base e, some power to the base e. Here is the power to the base e. What is small e? Base of natural logarithm. What is the value of small e? 2.718. 2.718. Such functions in mathematics, they are called exponential functions. If any physical quantity depends on exponential functions, then its formula cannot be derived using dimensional analysis. Correct? And last limitation, remember we were writing some proportionality constant, but its value was determined every time experimentally. So value of proportionality constant is not known from dimensional analysis. We were finding that constant using experiments. So these are the 4 limitations of dimensional analysis. Okay.
Now can you read the statement of number 11? Read it? Look. You know distance equals to velocity into time. Distance travel is equal to velocity into time. Correct? Now we are asked to find out new unit of distance. New unit of distance, because we are given new units of velocity and time. Let us consider. Come on. New unit of velocity they have given as velocity of light in vacuum, which is 3 into 10 raised to 8 meter per second. Okay. New unit of time they have given as 1 year. 1 year. 1 year means 365.25 number of days. So I have written here number of days, 365.25 number of days, but 1 day is 24 hours. So I am multiplying by 24. But 1 hour is 3600 seconds. Okay. So multiplying by 3600. Come on. Year to days. 1 year is how many days? 365.25 days. But 1 day is how many hours? It is 24 hours. Correct? And 1 hour is how many seconds? 3600 seconds. So I am multiplying by 3600. Got it? this into this, that whole product comes out to be 9.468 into 10 raised to 15, and this second and second will cancel, giving you that many meter, correct? But same distance is also known as 1 light year, 1 light year. So I am writing this equals to 1 light year, correct? Symbol of light year is small l small y, okay? So remember, 1 light year is 9.468 into 10 raised to 15 meter, okay? Fine. Can we read now statement of number 12? Read it? Look. We are asked to find out new unit of force if 10 gram is taken as unit of mass, 10 centimeter is taken as unit of length, and 0.1 second as unit of time, correct? If these three values are taken respectively as new units of mass, length and time, then what will be new unit of force? Let us find out. See, first of all, you must write down the dimensional formula for force. I told you to remember this formula because it will be utilized many places, okay? Please remember, come on. Dimensional formula force was m raised to 1, l raised to 1, t raised to minus 2. Same formula written here, m raised to 1, l raised to 1, t raised to minus 2, correct? But now, this unit of mass is the new unit of mass, and which they have given as 10 gram, okay? Don't forget to write down this power, okay? Come on, new unit of length they have given as 10 centimeter, okay? Raised to 1, and new unit of time they have given 0.1 second, whole raised to minus 2, correct? Now tell me, 10 as it is, but 1 gram is 10 raised to minus 3 kilogram, correct? Whole raised to 1. 10 as it is, 1 centimeter is 10 raised to minus 2 meter, correct? Whole raised to 1. 0.1 as it is, second also as it is, whole raised to minus 2. Now tell me, this is 1 minus 3, that is minus 2. Minus 2 into 1, that is minus 2, correct? Come on, 1 minus 2, that is minus 1. Into 1, that is minus 1. Come on, this is 10 raised to minus 1. 0.1 means what? 10 raised to minus 1. Minus 1 into minus 2, that is plus 2. So I am writing 10 raised to plus 2, correct? What about unit? Unit will be kilogram into meter upon second square, because this is second raised to minus 2. Second raised to minus 2, if we bring down, it will be second square, correct? This is unit of mass, this is unit of acceleration, and mass into acceleration is nothing but force, and SI unit of force is Newton. So in place of this, you must write now Newton, correct? But what about multiplier? Come on, minus 2 plus 2 will cancel, giving you 10 raised to minus 1. 10 raised to minus 1 means 0.1. So 0.1 Newton, 0.1 Newton, correct? So if 10 gram, 10 centimeter and 0.1 second are taken respectively as new units of mass, length and time, then in that new unit system, new unit of force would be 0.1 Newton, 0.1 Newton, correct? Can we read the statement of number 13? Read it? Look, we are given one equation, and it is Q equals to Ka T1 minus T2 upon L into T. Let me give you identification of each symbol. This is the amount of heat energy, this is the thermal conductivity, this is the cross sectional area, this is the temperature difference, this is the length of the rod, and this is the
given time. Okay. Now, using this equation, we are asked to find out dimensional formula for this thermal conductivity, that is small k. So, first of all, make it subject of the equation. Find out k from here, correct? Come on, k as it is. Now, find out k from here, it will be q into L upon A into T1 minus T2 into small t. Okay? Just make k as subject of the equation. And now, because you want dimensional formula for k, you must write down here dimensional formula for all these quantities, correct? Let us write down. Come on, this is amount of heat energy. After all, it is some form of energy. For energy, you must write down the dimensional formula for work. And what was the dimensional formula for work? It was m raised to 1, L raised to 2, T raised to minus 2. M raised to 1, L raised to 2, T raised to minus 2, correct? For length, it is L raised to 1. For area, it was L raised to 2, L raised to 2. For temperature difference, it is Kelvin raised to 1, Kelvin raised to 1, K raised to 1, capital K. You must write here capital K, okay? And for time, T raised to 1. Now, simplify. You will get m raised to 1, L raised to 1, T raised to minus 3, K raised to minus 1, correct? Come on, m raised to 1 as it is, L raised to 2, L raised to 2 will cancel. This L raised to 1 I have written as it is, T raised to minus 2 minus 1, that is minus 3, K raised to 1 going up will become K raised to minus 1, correct? So, this gives you dimensional formula of small k, that is thermal conductivity, okay? Can you read now statement of number 14? Read it? Look. First, we are asked about electric charge. Remember the formula of electric charge in terms of current and time. It is Q equals to I into T. Charge is current into time. Okay? For current, you know dimensional formula is capital A raised to 1. For time, capital T raised to 1. So, now this will become dimensional formula of electric charge. Okay? Please remember this. It will be utilized at many places. Okay? Now, let us see number 2 about electric potential. You may call it electric potential difference or voltage also, correct? Let it be capital V. You please remember this basic formula. It is W equals to VQ, that is amount of electric work done is equal to electric potential difference multiplied by electric charge. Okay? But we know Q equals to IT. So, just place Q equals to IT. Correct? And now find out capital V. It will be W upon IT, W upon IT, correct? Now, we know dimensional formula of each of this. So, we can find out dimensional formula of electric potential or potential difference or voltage. Come on. For work done, don't you know, it is m raised to 1, L raised to 2, T raised to minus 2. M raised to 1, L raised to 2, T raised to minus 2, correct? For current, it is A raised to 1, capital A raised to 1. For time, it is T raised to 1, correct? Come on, m raised to 1 as it is, L raised to 2 as it is, T raised to minus 2 minus 1, that is minus 3, and A raised to 1 going up will become A raised to minus 1, correct? So, this is now dimensional formula of electric potential or potential difference or voltage. If you cannot remember this dimensional formula, no problem, but you must remember this basic formula, okay? Whenever required, you can just recall it and you can use it, you can find it. Got it? Now, we go for number 3. It is about capacitance. The basic definition of capacitance is C equals to Q upon V. This all definitions you will study in the 3rd semester. Okay? So, at present you can remember by formula C equals to Q upon V, where this is amount of electric charge, this is potential difference. Okay? Now, come on, Q equals to IT, that we know very well. And what about V? V is, come on, W upon IT. Come on, V is W upon IT, correct? So, this IT will go up. So, it is I square T square upon W, I square T square upon W, correct? And now, we want the dimensional formula for capacitance. So, just put it in such a bracket. and then write dimensional formula for all the quantities on right hand side. Come on, for current it is capital A raised to 1 whole raised to 2, so it is A raised to 2, correct. For time it is T raised to 1 whole raised to 2, so it is T raised to 2. For work done, come on, it is M raised to 1, L raised to 2, T raised to minus 2. Same thing I have written here. Now simplify. M raised to 1 going up will become M raised to minus 1, L raised to 2 going up will become L raised to minus 2, T raised to minus 2 going up will become T raised to plus 2, plus 2 plus 2 will become altogether T raised to plus 4, and this A raised to 2 as it is, okay. So now this gives you dimensional formula of capacitance, okay. Then number 4, it is about electrical resistance, Look, now dimensional formula of electrical resistance you can find out using Ohm's law, and the mathematical form of Ohm's law is V equals to IR, where V is voltage, I is current, R is electrical resistance, capital R is electrical resistance. And now we want dimensional formula of capital R, so just make it subject of the equation. So R will be V upon I, correct. What about V? V equals to, come on, V equals to W upon IT, come on, V equals to W upon IT, and capital I as it is, this IT will come down, so it will be W upon I square T, W upon I square T, W upon I square T, correct. What about dimensional formula of capital R? You can write down dimensional formula of each of these. For work done it is M raised to 1, L raised to 2, T raised to minus 2. For current square it is capital A raised to 2. For time it is T raised to 1. Okay. Now just simplify. M raised to 1 as it is, L raised to 2 as it is, T raised to minus 2 minus 1, that is minus 3. A raised to 2 going up will become A raised to minus 2. Correct.